All right, so yes, we decided to organize actually the first product-related announcement that Hammerspace has done since we went general availability on our code last year for today. So we thought it would be nice to use this as a venue to talk, and then you'll see a press release, which Fred and the team will email to you today as well, come out later today. But we wanted to use this as an opportunity to bring the news out. So great to see those of you who I already know too. Meet new folks. Okay, so how we'll spend our time together today with this session is first talking about the challenges that workflows have in the hybrid cloud and how Hammerspace and what we call the global data environment address those challenges. We have a couple of videos mixed in there, so product demo, so you can actually see the technology working. It's quite different than any other technology on the market right now, so we find that seeing it in action helps kind of understand the concept of what we're doing as the industry is shifting kind of from dedicated storage systems to what we're calling this global data environment. The news today is focused primarily on metadata and metadata-driven workflows, so we will go specifically into our metadata technologies that exist today for a bit, and then the news is related to new metadata enhancements, which we have coming out. I run marketing. Ian, who is our technical director for Europe, will answer any of the technical questions which I am unable to answer, so which I'm certain there will be ones. So definitely he'll be stepping in as needed to help me with those types of questions. For sure, please do ask questions as we go. If there's anything that's not clear, we would love to cover that kind of as we go. So if you look at what a global data environment is, and as the technology came into the market over the last year, we were looking to have a way to describe something new, a new way to interact with your data that was also fairly easy to understand for the users who are trying to implement technologies to solve these problems. To give you kind of a feel for why I joined Hammerspace, I've been here for about 9 months, was hired, I'm marketing employee number 1, building out the marketing team. About the same time that I joined, Chris Bowen, who runs sales for us, was joined to build out the sales team. He's since hired 6 sales teams, which Ian is one of the technical members of one of the sales teams, and he opened up Europe for us. A little background about Chris: he came from Avere, and he was part of the team who got Avere, into the market and then acquired by Microsoft. I worked at Quantum, Cumulo, DDN, and so I know file systems and storage systems well. And when Hammerspace called and started to recruit all of us who have joined the company, the piece that we've solved that really was unsolved previously is this idea of having global access to data, no matter who or where the user or the application sits, that they want to have access to their data sets. And if you think about technologies from the companies I've worked at in the past, they certainly have the ability to run storage clusters or storage systems in multiple locations, but you still ended out with silos of data, even within a single vendor's technology, and silos of data as you moved into cloud, object, S3, things like that. And users would really struggle with the problem of, they would want to, for example, one of the UK customers that we've worked with in the past, what they wanted to do was be able to take film, make it available to different regions who are making commercials from that film, keep the film secure. So one, they couldn't have it go off their networks and have it leaked out of their organization. It was large files, so this idea of data gravity or large files being difficult to move was a big challenge for them. And they needed to be able to collaborate across geographies. And when you look at the technologies that were available for Hammerspace to do that, it typically meant you had different storage systems, different clouds, some kind of data movers, maybe some scripting language. They've written some scripts to move things around. They could do it, but it was not elegant. It created lots of copies of data. Keeping track of the master copy of data was difficult. And then there was always concerns about, as orphaned copies of data get out there, are they be treated properly for compliance and security? And so there was always concerns. And organizations were really looking for a technology like this where it was not just a global namespace, but a global view into all of their data, where IT would have the ability to ensure regulations are met, data protection compliance of the data, while also having all of the data available wherever it's needed. So that's really the problem that we're solving. And I don't believe there's any other technology in the market doing it today, so it takes a little bit of explanation what we're doing. Once users understand it, they get very, very excited. So let me just kind of talk a little bit about it. So this idea of a global data environment is designed primarily for unstructured data. So, video files, audio files, images, log files, sensor data, things like this. Designed to make it where any user, application, data center service, or cloud service that is accessing the data can see all of the data in the environment. And when you hook up access of an application, a user, you hook it up over NFS or SMB to the global data environment. Everything that happens below that is transparent to those users. So everything that we're going to talk about after this, once you're hooked into the global data environment, even if you end of life a hardware system, if you add a new cloud storage system, add a new instance that you spin up for a month for elastic capacity in cloud, spin it back down, that's done under the covers without ever having to move your applications and your users around. So it makes it very transparent for users and applications to have continuity, while the IT systems or the IT management can take advantage of whatever technologies they want. They may have, these are all of our qualified technologies we'll continue to add over time. But on-premises file systems, on-premises object stores, the different cloud services, you'll see, for example, Snowflake. If maybe a customer wants to take advantage of Snowflake's analytics engines, but the data isn't sitting in Snowflake's cloud, that's okay, because you just have this Snowflake analytics engine connected to the global data environment, and you can run those analytics on data that's not sitting up in Snowflake. So lots of different partners that we have that are on the storage side. I'll mention just one other that I think helps kind of solidify these trends that are going on in the industry right now. So one of our big partners is Seagate, specifically for Core Vault, which is their edge hardware system, and Live Cloud, which is their cloud service. What they use Hammerspace for is to create a global data environment that gives a single global data namespace from edge to cloud, using their marketing terms, where they can run Seagate technology anywhere, and the customers are actually interacting with Hammerspace for their data access. So we're seeing a lot of the large system vendors wanting to have a partnership with Hammerspace for that kind of functionality. And then kind of the idea of what happens between these two pieces is this is all metadata driven. We'll talk about metadata here in depth, so I'm just jumping past that for just a minute. But then there's a lot of magic that happens within the global data environment, that when this user, who maybe is in London, requests a file that's stored in France, they're interacting actually with metadata, so they can see the files. And then we have a lot of data orchestration functionality built in that will make decisions on should the file move to another region, should it move to another storage system. And that orchestration decision is done on things like, what is the latency required? Will there be egress charges? What is the storage cost here that's appropriate for this data? So there's a lot in the orchestration policies that are built into this that, again, is managed by IT. But on this side, all these customers or applications are seeing is just a list of files to work with. So they don't need to know about all that complexity. And then if you talk about metadata, certainly we have metadata. And as I'm sure you all know, file metadata is not particularly useful. It's, how old is the file? There may be, a little bit of information, but we spend a lot of time enriching that metadata so that you can take do actionable things based on that metadata. So we're hooked into third-party applications that are vertical specific. One of our demos that I'm going to show you is one of these, so you can kind of see this in action. But you can also think about enriching metadata with technologies. There's a company called Veritone, which we're integrated with. Veritone processes rich media files, so video. Think like Hollywood film, and you can run its AI engines to create metadata of at which point in each clip does Brad Pitt show up in a video, and that they'll create that kind of metadata. And we can also, I like Brad Pitt, I have to use him as an example here, saw you chuckle. And so we can enrich our metadata with those types of that type of information too. So we hook into applications to enrich our metadata, but also to make it possible for, if a user is used to working with a third-party tool to manage their software or to manage their workflow, that workflow is integrated into our metadata environment as well. So kind of abstract, and that's why I have a video here in a minute that I'll show about this. To give you a feel for what it looks like from a user and administrator perspective, it very simply is, you can think about all those vendors I had listed there underneath the global data environment. They all have different storage. They have different data that's stored in them. We aggregate it into just a standard user view, like a normal file system that you would see on your laptop. That's what users see, and that's the data that sits in NetApp, Cumulo, Azure, AWS S3, just as a normal file structure. They see all of the data that they're given access to. So if they're allowed to see everything, they'll see it all. Maybe they're only allowed to see certain data. They'll just see the data that's been allowed. And every user sees the same data. So if all of us were hooked up into a global data environment, living in the various countries and whatnot that we live in, we would all see the exact same files and be able to collaborate and access these files without having to bring any third-party applications in.
And excuse me, just if you have on two sites, let's say pure storage array on each side, you have just one folder with pure storage and you have all the files because they wanted to have common files, or you have two folders, one for pure storage in France and pure storage in UK, for instance.
Do you want to talk about how that actually shows up?
Yeah, sure.
Sure.
Yeah, so depending on how you configure it, and you've got options on how you want to configure that particular
Okay, you can
environment.
do what you want.
So yeah, so if you have a data silo at site A, and you want to present that out as a global file share, and site B you want to present it out, you'll have two folders, one for that particular site and one for
because you decide to be siloed. Okay.
Because, yeah.
But if you want them to be common, actually you have only one folder and you can. Okay.
You can do, yes. You can basically bring the two mounts effectively under the same SMB share, NFS mount, and share them out globally together if you want to.
Okay.
And our thought process on that is a lot of users don't know which hardware is. It doesn't mean anything to them, you know. And so we don't require that they understand that. But if for some reason you want to expose which system it's on, you can.
Okay.
By the way, if the users are always seeing the same file and the same data, it means that you have a kind of system of copy management to do that?
We do. We do.
And it could be a golden copy?
I'm sorry?
And it could be a golden copy?
Yeah, so the way the copy management works is, I'm just looking back to see if there's a good visual, which I'm going to just jump slides here for a second to show a different visual. We're going to talk about this in a minute in more detail, but essentially all the users' applications that we've talked about are interacting either through a parallel file system client, which is PNFS, through a CSI plugin, NFS or SMB, so that's what they're interacting with. Here is, we actually have a metadata control plane or a metadata file system. That's what they're interacting with, is they're actually seeing the metadata as changes occur to files and those types of things. And then it could be that they just have one copy of data, you know, one version of each file exists and they're all sharing it. Or it might be that they want to have multiple copies for compliance reasons or whatever that might be. But in any case, they're just interacting with the metadata, and that is the master copy. It's the metadata's job to make sure they know who the master copy is. What we don't do, and what a lot of our kind of legal-related customers and companies who are worried about the security of their data, is we don't create orphaned copies of data. So the idea of making a copy in this system and this system, and then all of a sudden, oh gosh, that one's not encrypted, or this one wasn't supposed to leave the country, or whatever it is, you don't have to worry about that because that's taken care of with IT-driven policies at this layer. And not having orphan copies of data is a big thing in a lot of the organizations that we work with.
Say that again, in terms of the...
You can create objectives within the system and say, my objective is all of this data can't leave country boundaries. Maybe you're worried about sovereignty. And that policy will override anything the users are trying to do. So if IT has said, manage to sovereignty, and this user says, I want to move to a cloud region in Vancouver, even though I'm German, it won't let them do that.
Okay.
Just as an
and
example.
That's built in, or that's something that they have to
It's built
configure?
in to be able to use objectives that operate against the metadata. So
Right.
the metadata knows all these smart things, and then you can do things based on it.
Mhm.
But customers, I mean, over time as we get bigger, we'll have a community where they have these objective
Okay.
scripts they've written and
Understood.
can share with each other.
Makes sense.
Right now, since we're just getting started,
Mhm.
generally somebody like Ian or somebody in product would help them write their first few objectives,
Okay.
and we're kind of creating a library of them.
Okay,
Is
sounds
that the
good.
way you
Yeah,
would talk
yeah.
about it?
Yeah,
Makes sense.
absolutely, yeah.
Okay.
Yeah, it's about, we give you the ability to control it, it's up to you how you control it.
Okay.
But most of our customers are still learning. It's easier for us to help them write an
Yeah.
objective.
No, that makes sense.
So the only other thing I'll call out on this slide is, so that's what the user view looks like from an administrator side. And I know you can't see the screenshot very well, but what this shows is for all those different storage systems, let's say you have cloud and a couple of different vendor storage systems in here, IT can see everything from, is there a failure? What are the IOPS I'm delivering? Do I have SLAs on throughput? Am I running out of capacity? So it's a single management view of all those storage systems, while the users just see files. Is there anything else you'd add to there?
Yeah, but just that you can see all the data mobility. So if you created certain objectives that want to make your data mobile to different regions, you get a view of what that data mobility looks like at any particular point in time.
Another question, you use PNFS, which is already embedded in NFS 4.1.
Mm-hmm.
Why do you choose to just use PNFS and not the NFS 4.1?
We use both. So the Linux NFS kernel maintainer is a guy named Trond Michaelbuster, I think is how you say his last name. He works for us. So the guy who manages the NFS stack in Linux is one of our employees. So we choose to use NFS because instead of a proprietary client, for example, because we try to make this as agnostic to the environment where you use normal Windows tools, normal Linux tools to access your data. We do need the parallel performance. And Tron could speak to this better, which we don't qualify every single iteration of the various NFS stacks, and Tron makes the decision on which ones to drive through and qualify.
It's essentially performance driven.
Mhm,
The
it
reason
is.
for it.
Yeah.
That's the essential.
Yeah, but because it was embedded in.
Yeah.
performance-
He's the master of that
It's
stack,
already
and he decides what he thinks is
It's
best for
already
us,
when
and we just do what he
He
says.
sees 4.1 as a step backwards in performance.
He does, yeah.
So 4.2 is a vast improvement on performance. So, and we're all driven to giving you performance on these data workflows.
Fair enough.
So to the point of performance, when you think about where customers use us, and we'll talk about this a bit more later, but sometimes it is create this global data environment for existing data. But of course they have new data that's being created. So it's designed to be able to be the primary storage system to, maybe you already have all this data that's existed for a long time and you add a new genomics sequencer somewhere. You can connect the genomics sequencer directly to Hammerspace, and we make sure we have the appropriate performance profile to be able to be primary data. So we're not just collaboration, but what we find is some customers use us just for primary created data. Others are using us to collaborate on existing data. Others use us for software builds in the cloud. One of our big game development companies want to be able to have very fast DevOps software builds in the cloud. They use us for that. So there's a lot of different use cases for the technology that range kind of across that spectrum. I was just here, I was telling one of you, I was here at the HPC user conference yesterday looking at the French Exascale project and what they're trying to do to bring together edge devices / instruments, HPC, and AI. And this kind of technology is super interesting to them for something like that, even in a massive supercomputing environment. So how we do this and why this hasn't existed in the past is we essentially reordered the stack of the way file systems are built. This is the way it exists today. You have the user sitting on top. Their applications are accessing data management by copy. So copies are made in different systems, different locations, whatever it is. The storage systems typically create a silo, so an Isilon system's not going to be aware of a NetApp system or something like that. And then the file system is embedded as part of that vendor storage system. And that's why there's been all these constraints on what does this file system do? What does this proprietary vendor storage system do? Data management may be done by them, it may be done by someone else. And that's just the technology tool set that we've had available today. Nothing wrong with it, like that's just what has existed and made it difficult to unify data to the applications and users. What Hammerspace has done is moved the file system up the stack so that applications are interacting directly with a metadata files, a metadata control plane, and the file system at the top of the stack that is vendor agnostic as far as all the storage systems and those types of things, so that now you, instead of an embedded file system, you have a global file system that you're directly interacting with. The data orchestration, the data management is done within that file system. So everything is controlled by this file system now, so you don't have orphan copies and the things that we've already talked about. And that's done by policy. And then the storage system, you can continue to use multiple vendors, but they stay on the bottom of the stack, so no longer are you controlled by what their systems are able to do, but you can still take advantage of what their systems are able to do. So we reordered the stack. Our founder was the founder of Fusion.io, a guy named David Flynn, if you're familiar with him. So David's our founder and our CEO.
I think he knows about performance.
He knows a bit. And he knows a bit about kind of innovating on performance. Yeah, so it's fun hearing his stories and of, you know, what they named NVMe before NVMe was called NVMe. They had some other name, which some of you guys actually may know better than me. Something, yeah, some technical name. And so David is our founder and visionary, and he's been working at this for almost 10 years now. We have about $120 million of investment, primarily from him. We have a few outside vendors, or outside kind of angel investors, people like E.L. Waldman from Mellanox. You know, so performance people are very tied to this company. And he decided, you know, just the way this stack is ordered is wrong. And I've sat on the user groups for other companies, user advisory boards. I've, you know, worked with engineering on these other file system companies I've worked at. And doing this was just too hard. It's not like they weren't smart enough. They absolutely were, but they had other problems they were trying to solve and just said, we're not going to solve this problem with our, you know, our other NAS systems. Hammerspace went ahead and did it and is changing the way data architectures are being done. So what I'd like to do is take a minute here and play a video so you can actually see an application integration working, see what the technology looks like, and then we'll go from there. Any other questions before I jump into this?
Yes, I have.
Yes.
Actually, on local file system, you know, you have who created the file, when did the access, and it's different if it's NetApp storage or Windows storage. Do you keep all this kind of, yes, metadata, but actually it's metadata from the file system in your global file system? Can you still see who created?
Yeah, what we're doing is when we initially take over an NFS mount from the underlying storage system, we do a data assimilation, which is effectively extracting the metadata from the data blocks.
Okay.
Data blocks will sit still on the storage system that they were born on, and the metadata will move into one of our Anvil systems, and the Anvils will get replicated across all the sites that are involved in this. So they'll get that.
And it's all automatic. You don't need an administrator to re-enter the name of the...
No, it's a role-based access.
Okay.
It looks like a role-based access control.
It all hooks into Active Directory, so it has all the relevant permissions, etc. So you don't have to reaffirm file permissions or A-time
so
on
it
files.
takes already all the existing permission
and all the existing A-times, M-times, all that sort of data is pulled into the Anvil systems.
Okay.
Greetings. Today I'm going to talk briefly about how Hammerspace technology is being used to expand and accelerate production work.
I'm going to skip this part just because that is a little intro you guys don't need.
Not only cut costs by seamlessly extending their on-prem resources to cloud, but also to grow their business and rapidly expand their operations globally. Jellyfish initially adopted Hammerspace to reduce their cloud rendering costs. Render jobs that needed additional cloud resources were limited to their local Azure region. The problem is, because of their location, Azure compute resources in the London region are much more expensive than if the render could move to other regions where power and cooling are cheaper. With Hammerspace's ability to seamlessly bridge multiple cloud regions, Jellyfish is now able to route render jobs dynamically to whichever cloud region is cheapest. From a user's perspective, the workflow has never changed. Hammerspace is integrated with Autodesk ShotGrid, enabling users to schedule render jobs to Azure as they always have. But because the Hammerspace global file system can span multiple Azure regions simultaneously, render jobs can automatically be routed in the background to the cloud region where costs are lowest. This enabled Jellyfish to save as much as $300,000 on a single render job just because of the lower compute costs available in other regions, and with no change to user experience. To grow the company, however, Jellyfish needed to be able to take on more film projects. The problem was finding additional talent near to their London studios. To solve this, Jellyfish stood up Hammerspace instances in Azure POPs in Australia, India, and South Africa, effectively extending their London production environment so new teams in these locations could immediately begin working with the same user experience their London artists enjoy. Without the need to stand up new infrastructure at these locations or to shuffle data copies around the world, the remote teams were online and able to access the global data environment with no delay. Finally, Hammerspace enabled Jellyfish to tie a second Toronto-based data center into the global data environment. Now all users across all locations are able to see all of their data across all of their storage resources, including on-prem and cloud-based resources. In this way, Hammerspace has enabled Jellyfish to not only cut costs, but also to win new business with rapid provisioning and expansion. For the next few minutes, Hammerspace Solutions Architect Michael Bott will walk you through a condensed demo. It will show two views, one as though from a user at headquarters, and another as a remote user accessing the system via Azure. Both are accessing the same files in a global file system. And then he'll show you how they trigger a job with ShotGrid.
So you can see on the left side, again, I have the site HQ. On the right side, I have the site Azure. You can see on both of these UIs, they have a view of the global file system, between two sites. There's the local site and the remote site. So we can see local here and then Azure on the remote site. It's reversed on the other side. I do want to talk about the building blocks though. So the first thing I can talk about is on the infrastructure side, and I'll show you that on both. So at the top level side, I have two locally attached disks, and then I also have the Azure blob. And then I route those local storage volumes into something called local storage. And what that did is it automatically created an objective that I can leverage called placeons. And then I have something called a smart objective. So I have this waiting thin keep local, and then I have IP keep local. So I'm going to switch to the ShotGrid thing in a minute. You might chuckle if you've ever seen the basic demo ShotGrid setup, because those are the projects that I'm using for this demo. But they have three statuses defined. There's WTG, waiting to start, there is finished, and there's IP in progress. And we're going to show you custom metadata being applied by a ShotGrid events plugin. And setting that, and then these objectives are the things that are going to make the data local. So let me show you what this looks like. So there is a wizard that has a nice graphical approach to creating an objective, but we also have a language, effectively, that lets you describe the behavior of data. And this is a very simple thing. Hopefully it whets your appetite or gets your imagination rolling to how you could leverage this in your own workflows. So you can see here if get tag, so I'm using a kind of metadata that we call tags. If get tag, so SG status list is the name of the tag. Okay, you might recognize that from ShotGrid. Equals IP, then service level objective, that's what slow means, place on local storage. Okay, so again, that local storage is what's attached to the DSX. And if I go back over here to infrastructure and data and I go to projects, if I just mouse over the applied objectives, you can see my IP keep local objective. So I've applied it to the share. Usually that's best done automation, not interactively, because it can get kind of complicated. But you can apply this on a file granular level. In this case, I just want to apply it to the whole project share. Now, what I'm going to do is descend into projects on both of these sides. Let's get into an actual project. So we're going to get into this animation project here. So I probably have directories the way you probably have them named, after sequences and shots and so forth. Okay, so I want to point something out here. So this data is all in headquarters right now. Okay, you can see the remote column, it all says no. Whereas on the right side, the remote column, now the directories are not remote, directories are just metadata, right? So those are everywhere. But you can see the actual data, you know, remote is yes. I mean, and in fact, we can just send into the pictures directory with a bunch of stuff. And you'll see all of these are remote, including my Max DS store. So let's watch what happens here when we go to ShotGrid. So I'm just gonna go into pictures here. Remember, you've got remote no and remote yes in Azure. And I've got a fake workflow here wherein when I flip something to in progress, I want to move it to Azure. That's what the objective says. So let's do that real quick. You can see over here, let's get into the animation folder. Again, the right side, drive Z is Azure, drive H is headquarters. And one thing you'll notice in my Explorer view is that these look like regular files. That's pretty typical. These actually show that they're offline files. Okay, so there is some sort of signal to the user that there is not a local instance of that data. But that said, I can actually browse, no problem, right? I can do whatever I want. In the data over here, it feels nice and snappy. It feels interactive to that user. And you know, let's say I want to just go ahead and open a piece of data that's remote. Okay, this is what I'm going to do first before I fire off the shot. So I'm going to open this Apple, and we're going to create some rad visual effects on it. You can see that just opened, right? It was not a local copy of the file. It did take a moment. You saw the application pause, but here it is. Here's our Apple. And let me go ahead and let's make some cool visual effects on it. Okay, there we go. And then we're going to close it and save it. All right. And now what's happening in the background is that the Azure Anvil is letting the headquarters Anvil know that there is a change to that file. I can come in here, I can open that file, and you'll see it pause again because we're pulling down changes. There's my awesome visual effects, okay? Now, that's cool for on demand, but a lot of times you might have big files or a lot of assets that need to be worked on in the remote site, and you don't want those guys waiting while they're opening all of those dependencies for a scene they're working on, or something like that. So let's see what happens here. You know, you could have someone, a human, come in and say, okay, in this animation project, I want a particular sequence, okay? And in this case, any sequence will cause a data move, so I'm just gonna show you this. We can change the status of a particular sequence, okay? I'm gonna change it to in progress. Remember, in progress is what gets it moved to Azure. So we say in progress, and then over here, you're actually gonna see the status change here. You saw it just pop up. You can see the information about the event. And there's a lot of data in this that I can use to create a directory that corresponds to that sequence or shot that I just changed the status of. But you can see down here, we switched from waiting to start to in progress. And let me show you on the Hammerspace UI what's going on right here. It's already aligned. I guess it got ahead of me. This was pretty quick. Now, instead of remote, most of this data now, instead of saying yes, it now says yes cached. Okay, meaning there is a locally cached instance of that data in the Azure site. And so now, when I go to the Azure site, let me do a refresh on this. And you'll actually see the offline files indicator go away, right? So now I can open this. Let's open it again. We're going to our awesome VFX application here. I'm opening a new file. This is a different Apple picture. We've got lots of apples because I'm at the top of the alphabet. Let's draw some stuff on here. So, you know, and we've got artists doing work now in the cloud. Okay, maybe they're remote artists that are coming in using Teradici or whatever your favorite high-performance remote desktop technology is. And now I've got those files modified. And if I come back over to show you what they look like on the Hammerspace side, you can actually see now, although lots of other things are remote, now these things that I edited are starting to show cache. So you can see the system rapidly becomes aware of the remote changes that happen. So consider where you can go with this. Okay, you can drive behavior like, in my animation project, within one shot, I've got different assets that are going to be worked on in different locations. And you can select for that, these objectives. You aren't just confined to tag. You can select from any piece of metadata you want.
So I'm going to cut it off there, but hopefully that gives you kind of a feel for what this looks like.
To be clear, when you create an extension, that means from London you go to Tokyo or whatever, you need just to deploy Hammerspace, and it discovers, or you just have to configure to extend the global file system from London, or you create an under unit that you show as the global file system. It's a kind of a under part of the global file that you show as the global file.
Yeah, so any region you want to extend into, whether it be cloud or on-premise, you simply stand up a Hammerspace environment. That consists of two components: the Anvil system, which you heard Mike talk about in the video, and the DSX system, which is where the storage blocks are. And then you need a transport mechanism to get the data to the other side, and we use object storage to do that currently. So your Anvil systems all talk to each other directly, and they send the metadata updates. So they've all got a sparse...
It means it's a pure extension of the first
Exactly.
global file.
So we're not looking at copies of files, as Molly said at the
No,
beginning. Yeah.
that's why I asked you that.
Yeah.
That's
Yeah.
because
You're
could
looking
be
at the
a-
same piece of metadata. That
could be just an underlined local that you show
Yeah.
as a...
Exactly.
Yeah, it's an extension of the entire file system. So you're seeing an instance of the same file system everywhere. And the blocks that make up the actual files are then orchestrated in some way. And Mike on the video was showing you pull on demand. So I'm a user, I open up a file, it pulls the blocks to where I want them to be. Or we set objectives. And those objectives will say place on. So put the data over there so that it's local to the user. Or what he's also got into there is ShopGrid, which is an artist being able to go in and actually orchestrate that by typing in tags into the sequences and say, right, these sequences and shops, I want them to be available to an artist running in another location. And the objectives that run under the covers will automatically move those blocks for them, so there'll be a copy local of the blocks themselves. The file system, the metadata is everywhere.
Yeah, but it means also that you need to have sharing features for if different users are accessing the same file.
You're talking about global file locking.
Yes.
Yeah, so we don't do global file locking. We've seen a lot of people do global file locking.
Okay. And it's
caused
just a
problems.
checksum at the end to see what
Yeah,
I've shared.
so we do conflict resolution, and Molly's going to talk about something else in a bit that brings into that. But conflict resolution is that if you're editors and you're both working on the same file at the same time and save it at the same time, you've probably got more problems than you know.
No, it's always near real time. It's never.
What we'll do is we'll create two files in that case that an
Okay.
administrator can solve the problem of. It'll be a site ID and a timestamp on it, so that there'll be two files. So you won't lose data.
Okay, but
Two
how do
copies.
you decide at the end what is the right?
Yeah, so an administrator can go into the snapshot current directory and the files will be listed in there, and you can say, all right, so this one and this one, open them up, which one's the master, make a decision.
Okay.
Molly will talk about something else a little bit.
Yeah, we have a
But do
new
you have a kind
we have a
of
new
warning
announcement to get
or-
around that too. So that's part of today's announcements is a
Okay.
new technology that gets around that concern. So.
Okay.
Okay, so we're almost past, this is the last slide, kind of the overview. So essentially, what we're seeing is, as cloud has been out here now for, 15 years or so, some things that we have gotten smarter about how customers and users and applications want to use the cloud. We all know that most organizations have some data center, some edge, some cloud, and having strategies for their data architectures that integrate all of their data and aren't cloud specific or vendor specific help. But we also know that they're looking to access more brain power. So brain power could be in the form of an application was written in Azure that they want to take advantage of, but their data is sitting in their data center. It could be like the Jellyfish case study where they need to access remote talent. And of course, this work from home situation that probably is going to stay for a while, making sure these data-driven users have the ability to work from home effectively. Virtual desktops and virtual machines are part of the solution, but having the data local enough to provide low latency, high performance, without orphaning off copies of data. This data infrastructure is the part that's been missing. And then accessing global compute. There's a lot of drivers as you talk to customers right now about why they need to access global compute. Some is supply chain shortage. They can't buy or get hardware in-house that they want to have access to. Some is they want elastic capabilities. They don't want to own all the CPUs or GPUs that they need for a specific job, so they want elasticity to their hardware infrastructure. End of Moore's Law, there's new specialized hardware coming out, as you think about hardware that keeps coming out in processors and memory. Sometimes the customer wants to access some of that, but they're not going to go purchase it and put it in their data center. So again, accessing global compute is super powerful, but getting data to that global compute has been really challenging. And so customers have the idea of, I would like to burst render or burst compute or use a specific type of technology, but how on earth am I going to get my data there? Mm-hmm. And that's been a massive challenge. And the piece that has been missing, we've been kind of playing with the term of the missing link, is this foundation that provides this agile global data environment to power all of those other technologies. And so the ability for an organization to take advantage of the remote workers, the remote compute, these different technologies has been difficult. And it doesn't mean it's impossible. They could script it, they could bring different technologies together, but then there's challenges that we've already talked about around security, copy management. Do I actually have the skill set to do that? And that's that's what Hammerspace is solving, is offering the foundation that gives agile global data to these agile global compute and agile remote workforce environments. So jumping into a little bit more, I'm going to skip that, about our metadata. So I'm going to talk a little bit more about our metadata and then talk about what's new in our technology. So to give you the foundation of, we already showed this picture of where the metadata control plane is. It sits within this parallel global file system. As I mentioned, we've moved it up the stack, and so instead of the file system being embedded at the bottom, it's at the top and controlling everything underneath it. So that's an architectural change versus what you're used to seeing that I just kind of emphasized to frame as we start to talk about what our metadata does. So you go into an environment, and most companies, let's just use NetApp as an example. Almost every company has a NetApp somewhere. They want to integrate the data off of their traditional NAS environments into Hammerspace. We do something called metadata assimilation, and that's done in place. So what that means is we go take the metadata about the data sitting in this system and put it up into the Hammerspace environment. That takes minutes, maybe an hour. It's very, very fast because the data is not actually moving. So all those things that we're used to hearing about of, a data migration project takes days, weeks, years, depending on what it is. We're leaving the data in place. So one, it's fast. Two, it doesn't require...
Just one question.
Yeah.
Is it general metadata that you have on every NAS, or is it the metadata from the Dell EMC API, the NetApp API, the Pure Storage API?
Do you want to speak to that?
Good question.
So we may not be able to give you the precise answer to that, but every one is different. So we have to do specific work with those vendors. So we have a partnership with NetApp to be able to do the metadata assimilation. Cumulo worked with us to do the metadata assimilation. So it isn't just the generally available stuff, but if it has everything, I don't know. But
so
it is collaborative. Yeah, you could kind of, I think, call it co-opetition, that they want to have, because we're taking over the names. At this point, we're in the data path instead of them. And that might not be something they really want, but if they have customers who need a global data environment and they're not able to provide it, they'd rather at least keep the hardware footprint and what they have than have the customer leave completely. So I'll just give you a couple examples. We just, a couple days ago at the end of last quarter, closed our first deal with Pure Storage, and that was for using our global namespace in front of FlashBlade, doing things just their technology can't do, and they're happy to work with us in that case. Our first Cumulo customer was a customer that had started with Cumulo, loves them, put them in a single data center, but as they grew, They now have 4 data centers and need to unify their data. They're a manufacturing company across those 4 data centers, and it's just something Cumulo doesn't do. So Cumulo is still there. We're adding value in the software layer. So that's why they partner with us, for us to be able to do this metadata assimilation.
But until the moment they have the data volume on the machine.
Say that again?
They partner till the moment they have the data volume in the machine, on their machine.
Right, sure. So we do data in place metadata assimilation. So implementation of adding Hammerspace to an environment can be done very, very quickly. Within a day, once you figure out what you want to do, you can be connecting your users to Hammerspace instead of to the different storage environments they had. So it's fast. The other thing that's cool about that is, let's say you had some hardware that's going to end of life, but it's not for a year, until 9 months from now. You can go ahead and implement Hammerspace, and when the time comes that you need to migrate off of your old hardware to whatever the next thing is, that can be done asynchronously. You can manage your hardware budget and policies and life cycles separately from any of the data initiatives you have. Once you're doing data assimilation, there's 2 different ways companies can run. Most of them run in this fully managed sort of way, which is the idea of we assimilate the metadata. Now all users and applications are interacting with us, not with the storage system that they had in the past. But there is a sidecar mode where you could essentially do a metadata assimilation. Let's say you're thinking of a genomics environment. All the genome sequences are assimilated into Hammerspace, but your genome sequencer is still talking to your isolon. We can do something kind of like an incremental assimilation where you can go back and get more genome sequences without becoming in-band. We don't have many customers doing that. Most of our customers are in the fully managed environment. But you can think about a couple of environments where maybe you're using us primarily for like a shared read-only library of content or something like that. That option is out there, but it's not very common.
So for instance, let's imagine we have a NAS that share its content only with SMB. Thanks to your solution, we can access to it in NFS.
That's right.
Okay.
Yep, yeah, cross-protocol file sharing, correct. Okay, so the types of metadata that we have is kind of your standard file system level metadata. This would be the stuff that you're getting off of other systems. Things for enhanced metadata can be generated sometimes by vendor storage systems, other applications, those types of things where we have something like ShotGrid who's maybe adding more information or metadata into the system. We have a new announcement that I'll talk about in the compliance space today that will kind of fits in this area. Then there's auto-generated, which is more detail about things like what Mike Bott was talking about. Where is the file sitting? When was it last accessed? Is it local? Is it not? There's things that we're adding. There's also things like Lambda functions that can be adding in the serverless world. When the data is moved, so if the data has been moved, maybe there's an objective that says certain file types should meet a certain cost model, and knowing that it's been moved into S3 instead of off Flash or something like that. Those are all pieces of metadata that we're actionable on. We also have had very basic user-defined metadata in the past. This is an area that has been generated primarily by scripts up until now. So some kind of scripting, as Mike Bott was showing in that video, was used to create user metadata. And then we try to have it have the concept of inheritance. So metadata can be inherited by types of users or types of groups of users. So all of this is functional because of our capabilities with metadata. And it's particularly important because that data management now sits under that layer. So data orchestration occurs based on the metadata that exists. So because we have smart, actionable metadata, you can then automate things like data placement, security, which files need to be worm. Maybe you're worried about ransomware and there's certain policies you want to have built in. All of that can be done. You can say, for example, on my ransomware protection, I want to have any data generated by a specific department, not just read-only, but you have the ability to have undelete. All those different things are managed within the orchestration that's below the metadata layer, so it's actionable and customizable metadata that makes all of this possible for you to be able to do.
So let's imagine on one side you have an existing NAS. Usually the user can access by the network to the NAS.
Yes.
And so a ransomware can do exactly the same. Now, thanks to your solution, so users won't access anymore the NAS directly, they access the Hammerspace
Still
service.
over a NAS protocol, still NFS. If they're using NFS to work with NetApp, it's still NFS, it's just us.
What I'm asking is, so the user now, to access their data, they have to obey to the rules you have in Hammerspace. Not, for instance, if you lack some rules on the NFS because you are too lazy to make some protect your NFS, for instance, but you put all the protection in the Hammerspace. So does it mean your NAS is protected now because people only access the files through Hammerspace? Or if there is a ransomware, it can still attack the local NAS. Does Hammerspace break the direct connection between the client and the NAS?
It does, yes.
It does.
And so we've had to build in all the enterprise functionalities that you would expect from a NAS into Hammerspace. So anything you would expect around enterprise data protection, availability, security is built into Hammerspace. And so otherwise they wouldn't be able to do this, right?
Okay.
So yes, this has all the functionalities that you would expect. I mean, you could probably argue, there's something we don't have that NetApp does, but in general, everything that you expect from an enterprise data management is built into Hammerspace so that you can use this just like any NAS and not be sacrificing security. And in fact, you could think about it as you're actually enhancing your security because when you set a policy on everything needs to be worm, everything needs to be encrypted, and everything needs to have file versioning, that IT can set that policy once and it will apply to all data. Instead of saying, oh gosh, did we set that on that new cluster that got implemented, or did a user copy data somewhere else and it's not getting those policies? Like the enforcement at a global level is simpler and more complete than if you have to do it system by system by system.
Yes, but my question was more about what you just said about air gap. So you said you can have some portion of data that are warm, actually, if I understand well.
Yes.
But in reality, this data is not with the air gap. It's just on the network on the NAS. So when we go through the Hammerspace solution, so now the storage that is not on air gap is now on air gap. So now it's protected thanks to Hammerspace more than it is naturally.
You can no longer directly access the data from the existing storage because the metadata has been removed. Because the way that we manage the blocks in the underlying storage is by putting a cone structure in to be able to link data blocks to metadata.
Okay.
So you need to access it through Hammerspace to be able to get that full picture of what the file is.
Okay, so that's why you can have a worm actually on Hammerspace even if there is no worm on the.
Correct.
Yeah.
That's right.
Okay.
And you can, ransomware is a big topic right now. There may be customers who will still use a software that's designed just for ransomware. There are many, many specialized software tools out there that it doesn't mean, so for example, we're a partner with Veeam. Customers may decide to do their data protection and backup in Hammerspace, or they may say, I really need Veeam for my virtual machines or something they have. That's totally up to them. And we're never going to be as good as a specialized ransomware company or a specialized backup company in some of those areas. And so as customers implement Hammerspace, sometimes they still use those tools, or sometimes they'll say, this is a lot better in ensuring compliance across all my data, and I'm still going to use a specialized ransomware thing for something. So it really depends on the customer when they bring in one of those specialized tools. And again, we're just a NAS to those tools. So if it works with NAS, it works with Hammerspace. It doesn't require, we test with them, but it doesn't require some brand new level of code development or something to work with us. We just present as NAS to them. So we definitely take over the majority of data architecture, data access, and can do a bunch with data protection. But if a customer wants to continue using something they have and put us under their Commvault management, they certainly can do that. Okay, so let me jump into what's new. So we have done a lot with metadata in the past, and now that we've been in general availability for about a year, we've found that there's some things specifically that our customers are asking us for. Just to give you a feel for the kinds of organizations we run in, you saw a demonstration of a visual effects studio. We're used in post-production and media a lot. Online game development, the biggest online gaming companies in the world use us. We are used in legal a fair bit for both compliance as well as digital discovery. Life sciences is an area that we're used a lot. And then you can think about in universities, we have a CSI plugin. So if you think about the universities' locations where they have a Kubernetes environment, they have multiple locations, they want to share their data across different facilities and locations, we're very popular there. But we could throw out that unstructured data market that shows. We're also in research and in manufacturing quite a bit. So one of the largest private rocket makers out there uses Hammerspace. These are all companies we don't have public case studies on yet, but we're used in a lot of the kind of big unstructured data spaces that you could expect, as well as in empowering and enabling AI and ML workflows. So think about the value of an AI job, or if you're trying to train a machine learning model, you need data to do that, and getting those models able to access all of your data, your entire petabyte, versus just a directory you've copied to it or made available to it, it empowers those types of workflows a lot. So those are the kinds of environments we sit in. And of course, we're getting a lot of feedback on other things they'd like us to be able to do. So there's always been a struggle between how much should IT control and how much should the user control, or IT's like, hey, Mr. genomics researcher, I would really, really like you to archive off your projects when you're done with it. And the user's like, nah, I don't want to do that. We've all talked to every organization that this is a constant struggle. What we try to do is make it possible with this release now that IT and IT operations can set the global policies on the data, and we're giving the users some more control of the things they can do. So simplifying their ability to have user-generated metadata, giving some control to the users. So if they want to be able to do things like file versioning, they can do that themselves without having to get into the Hammerspace environment. So maybe they want to roll back to a previous version of a video clip or a file, a PowerPoint file, whatever it is. They don't have to call IT and open up a help desk ticket to do these things. We're giving some more user abilities into these environments. What we're calling, the question you had earlier about file locking, we already had collision handling, but we have added in the ability to do reserving write permissions, and I'll talk a little bit more about how that's done. And that's done at the user levels. Some enhanced security and audit for user activities. So you think about, okay, we're opening up the ability for users to do stuff. We need to make sure we can do this in a secure and controlled way so we know what they're doing. We can't just let it go out into the wild, or that can cause issues. And then we've designed most of our data environments so far was really designed for kind of like the machine-generated massive unstructured data. And we have customers who want to use this for their kind of document architectures too. So, PDFs, Word docs, things like that. And our metadata originally wasn't designed for that as much. So we have a new partnership that we have in place to address that. So let me talk about the first part. We have a new, what we're calling the Hammerspace metadata plugin for Windows, but it's generally for operating systems. The first one available is Windows. And essentially what we've done is create a metadata plugin that makes it possible from your Windows desktop to right-click and create custom metadata tags as a user. So you could say, one is for finance data, one is for a research project, maybe one is for marketing, those types of things. So you can actually categorize your data on your own. And while this has been a capability of Windows, it wouldn't inherit into the storage system. So what's different and what this plugin does is you can take advantage of this Windows functionality, and our metadata server will inherit those metadata tags. So users can now classify their data that's stored in a global data environment in the way that's logical to them from their Windows desktop, and don't have to go to IT and say, hey, create this way to tag my metadata. So you would never see, NetApp or a company like that. A lot of these capabilities you would have to go to IT, and an administrator has to get into the system, and then only applies to that one system. This is all about making the user able to tag and categorize their data how they want to from their desktop, from their traditional Windows tools. And we'll do this for Linux and Mac as well. Anything you want to add to that? Okay. The next thing that's new in our metadata-driven workflows is the ability for a user to initiate their own file protection and recovery. So this is the idea, again, integrated directly into Windows. A user can turn on versioning within their files. And if they want to roll back, they made a mistake, they want to use multiple copies, there's a ransomware attack and they want a self-service, get access to their own versions. You'll see just Hammerspace is integrated, has a tab directly in their Windows GUI. They can roll back and see all their versions, just like if you were in PowerPoint and had versions. But this is for the entire global data environment, so data sitting in S3, data sitting on Isilon. Again, so kind of the way customers or users are used to working with data through Microsoft on just their machines, they have access to the entire global data environment now to accomplish that.
It can be also limited, correct? Sometimes you don't want customers to, clients to restore files and...
Essentially, the way you can think about it, so the IT policies that are set on the global data environment are the boss. A user can't do anything that breaks those policies. They can supplement it, but if they want to do something that would break the global policy, it won't be allowed to do that.
Thanks.
The file reservation policy is the piece that we don't call it file locking because we've seen issues with file locking related to performance, related to resource utilization, related to if the lock is occurring and then you can't get it unlocked. There's issues with that our engineering team have said we need a capability that goes beyond just collision resolution, but it's slightly different architecturally, so they say don't call it file locking. So we don't, we call it file reservation. But essentially, it's very simply put, you can reserve a policy where only you have read-write access, all the rest of us just have read access. So we can all see it, but only you can make changes to it until you release that. It's done on an objective basis, so it can be time limited, it can be, say you only get to do this for an hour and then it's going to be released. There's things you can do like that, but we are very much into a collaboration. It's not that common. Two people are really working on the same file at once, and usually the metadata collisions can handle it, but in an environment where it will happen, you can check it out, essentially.
Time observations is great for companies which have a kind of follow the sun.
It does. It very much does.
Could be quite good.
And like the game development company I talked about, that's what they're doing. They're follow the sun software builds occurring, and then they're trying to check them in. And when you are handing off across follow the sun, it could be very good for that. But then knowing that somebody doesn't forget to unreserve and go to bed, and now everybody else can't work until he wakes up in the morning. You could avoid that situation. Okay. Another new item in our metadata-driven workflows is global audit for file system operations. So an audit log of anything that's happening in any folder, deletes, renames across all storage types. So audit is a very common functionality to have in a NAS environment is required. Having global audit that's persistent across the system, across all storage environments and all user activities, we're finding is just something that we need to have. The other piece that has come up a couple times in this discussion is around security enforcement, that this also ensures that whatever access controls are put in place, you have a log to be sure that nothing has been broken by copies, moved to other storage types, things like that. So people who are concerned with that have the ability to have, you know, a legal discoverable audit log of what's happened with the data. And then the last thing, there's a company called Alchemy Data. This is the technology that we're always integrating with new software packages to enrich metadata. Alchemy Data is a company that does a lot around scanning Word docs, PDFs, documents, creating discoverable information about those documents for things like compliance and legal discovery. We can also, interestingly enough, users can create metadata that they want on what they want Alchemy to search for. So maybe in a specific environment, you know, maybe they know they're going into a lawsuit on a project called Apple. They could say, make sure you're tagging anything that says Apple, not Apple the company, Apple the fruit. You know, so that you could make it a discoverable thing as well. So companies, as we're finding, is they wouldn't just buy us, I don't think, for just managing their Office docs, but they want to be able to put their Office docs into Hammerspace too. So having this capability, this company is called Data Guardian, but what Alchemy Data does is creates that metadata, and again, it gets inherited into the Hammerspace metadata environment once it's been created.
They can enforce CCPA, GPD, all this kind of
Yes, or
regulations by objectives?
Generally. They have, if you look at their website, they have a variety of use cases, but that's where the request is coming from for us.
By
Yeah.
the control plane of the objective
Correct.
policy.
Correct. One of the questions I have gotten just recently talking about metadata more and more is also like, how does a user interact with the metadata? So if you wanted to interact with this massive metadata control plane we have now, historically it's been designed that you would do it through an application like Alchemy or ShotGrid, or some application is interacting with our metadata. This is starting to expand out for more user-related data, not machine-generated data. You can actually interact with the metadata and ask your own questions versus needing to write a script and use an objective and things like that to interact with the metadata. And we're just learning more and more how users, organizations, as they put more data in, that maybe they had a net app that was more this type of data, where their Isilon was more machine-generated data, and that as they want to move everything into the global data environment, some of these other partners are becoming necessary.
In fact, by analogy, Hammerspace is becoming a metadata cataloging.
Yeah, yeah. I mean, it very much is. And you know, the term our customers largely do call it is metadata-driven workflows. You know, you know, and we enable that across all the environments. Yeah.
But it means that you moved the spot from another level. It means that you can't lose metadata because you don't know where the data are.
Oh, for sure. It's very important we don't lose metadata. Yeah. And we keep many copies of it.
As a snapshot somewhere. That's a snapshot. When you've got the pointers, if you lose the pointers, you don't know where the data are, or if you lose the data, the pointers are useless. How do you manage to avoid this problem and to be sure that I will never lose my metadata?
So obviously metadata is replicated across all the sites, so you have a copy of that anyway. The Anvil systems are HA paired, so you've got high availability. And there's also a backup mechanism inside the system to back up the metadata as well. So you could say there's 3 ways that we protect it.
And I can enforce it also, or enhance it by a kind of a air gap solution somewhere, to have a tape outside to be sure that I have my metadata.
You can back up typically it backs up to disk, but then you can back that disk up to tape if you're paranoid.
Mm-hmm.
Only paranoid survives. That's the problem.
That's good and bad. So that was it. That's what our new announcements were around, is the 5 new metadata capabilities.
With this new solution, Hammerspace, which kind of use case and company you will target? Which is because it's quite sophisticated usage around the metadata. It's not for for all the use case that we have normally on just NAS or this kind of things, which is more a kind of a file swamp somewhere that I want to forget, and it's not totally not the same thing, not totally the same use case.
You know, so what we see is that organizations, you know, there's the idea that you have your data sitting in your file swamp, and then more data is being created and nobody knows what they have, and that's kind of a risk. You know, one, you would like to monetize your data. That's great. Some business person wants to make money off your data. But then there's also the risk of all these data projects, and you know, we don't know what Ben created because he no longer works here, and all those different issues. So in a lot of cases, that anxiety a IT person might have in their stomach about they really don't know where it is it protected, can we derive value from it, gets addressed. As customers absolutely use this just as a big fat NAS that spans environments. They absolutely do. All these functionalities that we're now seeing largely are going into places where you have workers who are working on the data that are not IT people. So a scientist, a researcher, you know, somebody in the supercomputing space who's doing a meteorology, a weather forecast, and they have different metadata that they want to work with about how they're modeling weather forecasting than what a dumb NAS would do, you know, like, so they want weather industry specific tagging. You saw an example with visual effects, you know, that they might want to tag, a user might want to tag everything with apples in it and be able to find it. So when they go back and they're doing their next film sequence, instead of having to create their apples, again, they can just use something from the library that exists. So generally, this announcement is for organizations that have individuals who are working on the data, and it's industry-specific workflows that they would want to do something with. But generally speaking, and the only exception to that is this Alchemy data integration, which is very much designed for legal and compliance organizations. Legal discovery, things like that, where we have customers in that space right now that are asking for this. But generally, the idea of this global data environment is really targeted to organizations who, you know, kind of use the marketing terms, you know, are data-driven organizations who want to monetize their data. Like, that is the type of company that we're targeting, that if you could monetize your data swamp by getting it into Snowflake's analytic engines, imagine what you could do as a company. I mean, those are the companies who talk like that, generally are targeting Hammerspace.
No, but because Snowflake now is more a data backend.
Yeah, and you can...
And you work on that.
And it doesn't have to be Snowflake. It could be the latest, you know, engine that AWS has or whatever it is, you know, where they're trying to get data to humans or applications that can use that data to create insights. You know, in the manufacturing space, we had a customer who decided to move to Hammerspace because they had orphaned copies of data that led to the incorrect gold copy or incorrect copy was used, and the part didn't fit when they actually manufactured it for the vehicle it was going into. And it was like, you know, if they had just a single gold copy, that would never have happened. You know, so it's those types of environments that are adopting us at large scale right now.
Another question is around metadata need to be somewhere. It means that you have a kind of an object store embedded in the solution somewhere.
Not embedded, but we need to have an object store, yes.
As a backend, okay.
Yeah, so
and where it is, and which one it is.
Yeah.
Everything you want?
That's up to you.
Yeah, I mean, we're
Oh, really?
partnered. Yeah, it is up to you. We're partnered with
all the object
Cloudian.
store which are,
We have some customers who use, let's say, Cloudian and Equinix data centers that have really fast pipes,
So-
and they use that. Others
Okay.
use S3,
Wasabi,
Wasabi.
Backblaze.
Seagate Live has their own.
But does it mean you need some kind of proxy within data next to every site?
Yes.
Okay.
Well, let me, I see you hesitate. Maybe it's very
Not
human.
necessarily a proxy, but it's you need to have a copy of the metadata at every
Yeah.
site, yes, which is on the angles.
And so, is it big? Is it expensive?
it depends on the volume of the metadata.
Yeah, it depends upon, you know, how many files and directories you've got in your environment. But you've got this on commodity hardware, so
or cloud instance, it can be cloud native.
It can be VMs.
So in the Jellyfish case study, they will spin up, a new region to do a burst job, and in the cloud in Azure, they'll spin up an instance of the metadata in the cloud locally to the render job, and then knock it all down at the end.
Yeah, in fact,
So it can run bare metal, it can run cloud native, it can run a container.
In fact, that's an object store like Stadera, Backblaze B2, or Wasabi, or there's no
Backblaze is,
value on the object store. It's just
Backblaze is a partner of ours.
Just a push and pull.
Yeah. But they offer some important technology for us moving data around and things like that. So we aren't a storage company. Oops, sorry for those of you in my ear. I'm hitting the microphone.
Just
Bam, bam, bam. So we don't sell storage as a company. There's lots of good storage out there, and we like to partner with people to do that. That's invention that doesn't need to occur. So we take advantage of the great stuff that can happen in erasure coding and file movement and things like that.
Data management.
Exactly.
It's
Exactly.
data management. It's not storage.
Yep. Anything you think I missed? That's not what he says once the
Don't believe
microphone's
it.
off.
Don't believe it. It's English. That's it.
Anything else you have just questions? That's
So-
our presentation, but if you have other questions, we're happy to
Thank you
answer.
very much for this effective presentation. Where do you see Hammerspace in 5 years in terms of competition and meaning, turnover and,
Yeah, so our founder has run very large, successful public companies in the past. That is his intention for this company. I think what you'll find is the cloud companies, in some ways, you can think about them as proprietary vendors, just like all the other storage companies. Like Amazon's designed to run with Amazon. Azure's run to design with Azure. NetApp's designed to run with NetApp, generally speaking. And as you think about organizations' desire to have, a cloud that ensures sovereignty in Germany, or, Seagate comes out with a new thing, like organizations don't want to be stuck with a single vendor, including a single cloud vendor. And having a data fabric like this that it creates a global data environment that stitches together different clouds, different data centers. It's hard to imagine, like our founder David doesn't want to have it just acquired by Amazon to make Amazon better. Like he has a passionate desire to make this where organizations have the ability to use data across environments and have flexibility and enable them to use Amazon when they want to and NetApp when they want to. And so I think we'll be a standalone company that will probably be quite massive just based on the growth rates that we have, that helps users accomplish the objectives they want. And if we got acquired by a big systems company, whoever it was, the value would be much smaller. So I don't see that happening. I mean, who knows? Can't predict the future, but that's not what he wants.
great, thank you.
You bet. Any other questions?
That's quite, it's more compared as the last time I met Hammerspace, it's quite a strong evolution. Last time I think not less than 1 year.
Mm-hmm.
It was not the same messaging that we had.
Well, they have a marketing team now.
Yeah. But,
David is a technologist. He's not a marketer. But no, it's,
Oh,
and
I'm
You'll-
sorry.
we'll just cut that
I'm sorry.
but it's also the pieces that you've seen over the years are all part of this. Like when we did our Kubernetes plugins, when we created the data services layer, all of those are part of it. And what really, when it all came together, was when they released the global namespace with the parallel file system sitting on top of it all, and then kind of some messaging around why. And we understand what customers are doing with it now too.
since the last time we met them, they look more a ramp-up company.
Yes, for sure. And really, I mean, they went for, like I said, about $120 million in about 8 or 9 years without a marketing team, and they were just so focused on, when I joined, there was like, give or take 50 people. Finance, everybody was done through contracting. It was all engineers. I mean, they were just heads down writing code. And they did have a website, but, like it's only in the last year that they've brought in sales teams, professional marketing. We actually have a finance person that we pay now, but David was really focused just on the technology for a long, long time.
Yeah, but it was always some lag on the way, because 40 people doesn't work as 400.
Of course, yeah.
And so on. It was always a little bit lagging behind, and this impression to it will be always in the next version with Hammerspace.
Interesting.
It will be always in the next version. And
Interesting.
it looks that today they have more to announce than before, because it was not in the next version.
Yeah, so we're at the point where it's kind of a mature development model where the code is all general availability. Now we're in the releases, and so this release was focused on metadata. The release that the announcements that we have coming out next month in November when we're at the Supercomputing show are all performance related. So we're kind of on a kind of normal post general availability cadence now for releases.
And what's the plan to go to market in EMEA? Because if you're here, maybe you have good reason to be here.
I do. Actually, we're announcing, so we already have a distribution partner who just got acquired. They're called Spinnaker. They got acquired by Climb. So we've just signed a new distribution partner, which actually we're announcing tomorrow. So I'm glad you brought that up. I didn't make a slide about it because it wouldn't be an interesting slide. But so Titan Data is a new distribution partner that we have in Europe also. So we're going up there tomorrow to do some go-to-market training and planning.
Direct offices?
So we have office in London. Ian and his partner. Ian.
Sorry, it's no more Europe.
It's not. So
sorry for that.
No, it's true. So we have local partners, and Ian can speak better to who the partners are.
Sometimes it's not sufficient. You need to have a pre-sales guy,
totally.
Support guy.
Yeah. So our next hire is local support, so that we're actually, because we have so many customers, that having more customer support is actually more important than more sales right now. When we'll hire a sales team, so just very generically speaking, probably post raising Series A is when we'll hire more salespeople. Right now, we have plenty of pipeline, and the ability to implement and support is more important for our money right now. So sometime post Series A is when we'll have more field people. Customer support will be the next tier locally, and then. And
to be more clear, it means that it will follow the regular plan: UK, DAR, Germany, France, South Europe after.
We have been very careful about the types of sales teams we hire. So sometimes it's more opportunistic about if we can get a really killer sales team, and it's not where we were planning to hire, we'll just do that, versus focusing on geography. So sometimes we do it opportunistically. Like there's some people on the market right now who would very much like to come work at Hammerspace, and if it was somebody in France, but the traditional was Germany, we would hire a great team in France first to get the right people in. So I don't know is the answer. We weren't planning to open the UK when we did, and then I called these guys and was like, hey, Hammerspace is pretty cool, because we'd worked together before, and they decided they wanted to come over, so we opened up actually Europe faster than we expected, even through the UK, just because we could get a team that we knew would be really good at this technology. So sometimes it's opportunistic. But generally, yes, it would be the major economies in Europe would be the next place that we put people.
There is a partner in France, Trackit. So Trackit is based in, we've got French partnership, so we're doing quite a lot of business through them in France currently. Probably, I would say that that's got the most traction at the moment is France with the technology.
Do you know Trackit, just out of interest? Ludo in that group? I actually had a video from them I decided not to play just for sake of time, but they're an AWS cloud integration partner. So they're really good at deploying in AWS, and they've integrated us as part of a lot of the Amazon functionality, and then help customers actually deploy, because a lot of customers don't know how to deploy in Amazon even if they want to, and they do all of that for them, including deploying Hammerspace as part of it.
You can add the slide of them.
It's actually there, actually. And what you guys receive is in here. I'll put it up here. just so you can see, this is actually a video from them. Just while we're chatting, I'll put it on. I just didn't want to run out of time and get the dirty look from Fred in the back, so.
You're so smart.
But this
No hard stop. No hard stop.
But this actually is, and you can see it is in the deck that you'll receive, this is our French partner track it, showing how they deploy in cloud and in hybrid and doing an actual demo. And they bring us in, so since their founder is a guy, his name is Ludovic, what's his last name? Anyway, he's from here in France. And he's very connected here, and so because they get a lot of the cloud integration partners, cloud integration projects here, they just then bring in Hammerspace for the functionality we were talking about. So it's just a little 6-minute video you can watch on your own if you'd like. Any other questions?
Not on my side. I think I've got everything now.
Great.
Stuff.
Oh, thank you.
Okay, thanks.
Great.